Okay, we will be covering chapter 1. So it will be an introduction chapter for the subject, and we will see some terms that will be used for electrical machine calculations. Okay. Okay, so the first thing that you need to understand is per unit system. Okay, so because we know when it involves electricals, uh, it will involve a lot of calculation, which can involve complex and also sophisticated uh, terms and also calculations. So what we will do, we have a system called per unit or PU system, which will be used to make the calculation simplified. Okay, so we will start with this subject, this subtopic per unit system. Okay, so an interconnected power system, typically a system containing several transformers and rotating machine. Okay, so like how we can see our TNB is managing the electrical power. We can see so many antennas are involved, so many transmission line, so many transformers. So interconnected power system. Uh, so meaning one, one place will have a power system, another place will have another power system. So when these two power system are connected and communicating, so that is what we call as a interconnected power system. So imagine throughout Malaysia or throughout the world, how many power systems are there and how many interconnected power systems are there. So this interconnected power system, we call it as a grid. Okay, power system grid, GRID, grid. So, so Malaysia will have a national power system grid, which cover certain place, because we know only certain parts of Malaysia is generating the power. So the other parts we will be using the transmission line to send the power or transmit the power. So we will have when we have this kind of big systems or interconnected power system, we surely will have a transformer. So we know the function of transformer is to step down or step up the power. So meaning in the transmission line, so let's say it's 132 kV power. So we cannot use 132 kV power for our household. We need to step down. Okay, from 132, we need to step down to maybe 400 something. Then we need to reduce to uh, 240. So 240 we can use for our electrical machine. So what will happen when we for our electrical appliances, let's say your laptop is straight away connected to 132 kV. So surely not only your laptop, you yourself, because of the electrical power and the energy transmitted, you will be burned. So we cannot have that kind of situation. So we need to use a lot of transformers and also rotating machines in order to manage that power in and reduce it to a usable amount. So when we are involving a lot of machines and also transformers, of course we need to have a lot of calculations. So calculations for electrical, if you all know, if you all are familiarized with it, uh, so I'm not sure how many of you took physics before this. Okay, so if you took physics, I think you already learned a certain portion about mathematics related to electrical. So when the electrical machines and also the calculations, we have real part and also imaginary part. So we have two parts. So real part is something that you can quantify, and imaginary part is something will be in an angle, or it will be in. Usually, we will use the alphabet J. So later we will see some example. So we will have two parts. So the calculations for electrical machine you need to do for real part and also imaginary part in order to get the correct value that you want to use for the transformer or the rotating machine. So to manage this, so because we already know the calculations will be very difficult and complex, so we need to have a kind of system which can reduce it to a understandable level. So we use this per unit system, per unit, okay, per unit system, or we call it as a PU, KPU system, to simplify the analysis of complex power system by choosing a common set of base parameter in terms of which all system quantifiers are defined. Okay, so whatever things that in the electrical circuit, the calculation, we will be converted to per unit system to simplify the process. So that is why we per unit system is very important. So of course now we are not doing a manual calculation. So mostly we it's already computerized. But we need to understand uh, how the per unit system works so that we can use the software correctly. Because a slight mistake it will involve a lot of human life. So imagine suddenly something. Usually, what we will encounter if a wrong calculation or it will cause a short circuit, and that particular area will not have a current. But try imagine something like the transformer burn and it caused a really big disaster. So that's why per unit system will be helpful for us to understand the complex problem or the calculation better. Okay, so that's some introduction on the per unit system. Okay, the primary advantage of per unit system. So the per unit value for transformer impedance, voltage, and current are identical when referred to the primary and secondary. So we know the electrical machine, we will have a primary machine and also a secondary machine. So it will be helpful when we want to manipulate the values. Okay. So the per unit values clearly represent the relative value of the circuit quantities. So per unit value is not the actual value. We call it as a relative value. So meaning is in order to get this, so you are representing with another value. So that is what we call it as a relative value. So usually the complex value very hard to understand, but per unit value will be just a single number for you to understand. So when you see the relative value, you will know the magnitude of the actual value. So it will help to represent the relative value. So per unit system could be used to measure the performance of the electrical component without conducting complex power calculation. Okay, imagine I give you a question for final exam with a complex electrical machines and transformer. Uh, so of course you will take more time to do the calculation using the complex number. So if it's a mathematical examination, that's a different story. But when we are talking about this subject, so we want you to do calculation fast so that you can propose a solution because it's a theoretical and also practical subject. So per unit system will be helpful for you to measure the performance of the electrical component without conducting complex power calculation. Okay, so that's one thing. Okay, so we can see. So this is a simple electrical power generation. So usually you will have a generator, okay, generator to generate the electrical power. Then you will have some kind like a impedance, or you can have resistance, okay, involved. Then usually we will have a load, where one or two loads or more. Okay, loads are the end product. Okay, so usually it will be generated, it will be transmitted. So load can be anything. So let's say your refrigerator, it can be a load. So load can is something that the electrical power is used to. Okay, so load can be anything. So let's say this is your blender or this is your laptop. So load can be anything. So the final product that will be using the electricity. So we can see here, so the generator is generating 5% above the rated voltage. So usually it will be 1. So you start with 1 pu. Okay, 1 pu is the reference point. Okay, so everything start with 1. So based on this, we can see, so at this point, so the pu unit is 1.05. So it's not 1. So we know 0.05 is added to this pu value. So 0.05 times 100, so it is 5%. So we know based on this part, so the generator is generating 5% above the rated voltage. So that is what we can understand here. So now we can see the second part. So here the VC. So this is load. Sorry, it's not load A. So it is supposed to be load C. Please hold on. I will add it. Okay. So VC. So this is generator A. So because the value A at the back. Okay. Sorry, I think it's not in the presentation mode, right? Okay. Please hold on. Okay, can you see the slide now? Okay. Okay. So this slide. So we can see. So the generator. So generator. This is a generator A. Okay. So because it's using the alphabet A, VA. So generator A is generating 5% above the rated voltage because the value is 1.05. So the reference value rated voltage is 1. And for load, so this is load C because it's C, VC. So the load C has no drop in voltage. So it's 1 pu because what you calculate here is 1 pu. So 1 pu and 1 pu, so no change, no drop in voltage. So it will be either it increase, no drop, or as a drop. So and you can see here the load B, so VB. So here we can get the value 0.95 pu. So the reference value is 1. So how much differ? So the load B sees 5% drop in voltage. So we can see how it can simplify our understanding about the circuit. So if not, we will need to do a lot of analysis to understand. So by referring to these PU values, so we can see the generator as 5% above. So here 1 PU, no drop, and here 5% drop based on the value. Okay, so that is the purpose of PU system. So which is to simplify the process. Okay, the prime, sorry, is it the correct one? Okay, the definition of any quantities. Okay, so usually for electrical machine calculation, we will have a voltage, current, power, and impedance. So voltage we always know, we denote with V. Current is I. Power is, in calculation we will use S, not P. Okay, so if S is actually referring to power, and impedance we always denote with Z. Okay, so this is the definition for any quantity. So quantities per unit. So we can calculate by using the normal unit uh, divide by the base unit. Okay, so we can see here. So there are 4 base values that can be used. So V base. So V base is something that is given. So usually in the calculation, we will give this value, base value. So our voltage base value. So current base value, power base value, and also impedance base value. So based on this, we can calculate by ourselves. Okay. Once any two of the four base values are defined, the remaining two base value can be determined according to their fundamental circuit relationship. So this is the fundamental circuit relationship. Okay, so no worries. All these formulas I will give in appendix. So you don't need to memorize. You just need to know how to apply it. Okay, if I give this question in the exam. Okay, so we know there are four values. So as long two base values are given, so you can find another two base value based on this relationship. So usually the base value of power and voltage are selected. So common practice, we will give the base value for S and also V. Uh, so S and V, so you can just replace here, you can find this. So once you find I base, so you already have three, then you can use this formula to find Z. So once you get all four, then it is easier for you to find the other values. So we'll see one example later. Okay, the same thing. So earlier for single phase, so this is for three phase. For three phase, so once you find all the values, base values, then you just need to replace it in this formula to find the respective values. Okay, so make sure when you read the questions, you see whether it's a single phase or three phase. If nothing mentioned about three phase, so automatically it is referring to single phase. So you can use the single phase formula. So if the question say it's a three phase, and then you use this formula, okay, this calculation. So these formulas are also will be given in the appendix. Okay, so as a example, uh, so if you have paper with you, so try to find, or you can use a calculator directly. It's not so sophisticated one. Okay, so this question, so determine per unit value for all quantities, voltage, current, complex power, and also impedance. So we can see, so we have four quantities. Okay, and this is the actual value. Actual value is given. So base value only two are given. Okay, earlier we saw once any two of the four base values are given, so the remaining two you can find using this formula, these two. Okay, so try to find. Okay, so you try to find by yourself. So two base values are given. So but you can see actual value. This actual value, it has a real value and also imaginary value. So these are imaginary, the back part. So imaginary values normally we will give based on uh, this alphabet J, and we can have a phase shift. Okay, we can give an angle. Okay, so we will see how in per unit calculation it will be represented. Okay, so we can see. So this slide is not given in the lecture notes. Later I will give the updated one. I just add this for your understanding. So later you can get the updated one. So I will share in the group as well as in the Google Classroom. Okay, so we can see. So two base values are given. So based on this, so complex power S base is given 100 kilowatt and voltage is 120 kilowatt. Okay, based on this, okay, so one thing that you need to understand, when it is given in kilowatt, so make sure you expand it. Okay, so if 131, so don't take 131 and use here. It's supposed to be 131,000. So if you just use 131, you will get the wrong values. Okay. Okay, so replace this 100k kilowatt divide by 120 kilowatt. So kilo and kilo can cancel. Then you can get I base is 0.833. Okay, so that's the first part. Okay, so you're using this relationship, you already can manage to find 3. Now you want to find the fourth one. Okay, for fourth one, use this formula. Okay, so how to find? So you have two parts, 10 and also uh, 10 is the real part and j is the imaginary part. So we calculate for the first part. Okay, so you can use either one. Okay, so just take this easier. Okay, so V base is 120k. So make sure you expand it under 20,000 volt. Okay, and I is 0.833. Okay, so once you divide, you can get the value of Z base. Okay, so it is 1.44 times 10 to the power of 5. Okay. Okay, or you can write it in this format, or you can write it. I prefer you to write it in the full so that you won't do mistake simply. Okay, so you can write it down. It's supposed to be 144 times 10 to the power of 5. See, so 5 decimal, you just move. So it's supposed to be under 44,000. Okay, under 44,000. Okay, so once you find all these base values, then you can start finding for the imaginary value. Okay, so how you want to find this? You can replace in this formula respectively. Okay, so for voltage, use this. For current, use this formula. For complex power, use this formula. And for impedance, use this formula. Okay, so how you want to calculate? Because you have one side is a real part, and one more part is the imaginary part or the angle. Okay, first find the real part. So real part you find using this. So meaning for this, let's say for voltage, V is under 31k, under 31k. So under 31k divide by under 20k. So you're supposed to get 1.0917 pu. Okay, write it like this. Okay, for angle, it's a bit special. Just put the same angle at the back. Okay, if angle is given, so you just convert it the real part to the pu, then you just put the angle 30 at the back. Okay, so you already found for voltage. Now you go for current. So current also the same, 5.4 ampere. I divide by 0.833. So that is the base current. So you can get 6.48 pu. So the angle just put at the back. So no need to do anything about the angle. Okay, that is the phase shift. Okay, so we don't no need to change it. Okay, so let's say the actual value as an imaginary part. So what we need to do, divide directly. For angles, retain the same value. So angles retain the same value. For imaginary part, so divide directly. So here J is 70k. So make sure you take the k also. The 70k divide by 100k. 100k. So you get J 0.7 pu. Okay, how you want to write? So here you already divide. So 50 divided by 100 for real part. So you get 0.5 plus J. Uh, 70 divided by 100 is 0.7. So you write it like this, 0.5 plus J 0.7 pu. Okay, then for impedance, so you have two parts, real part and also imaginary part. Okay, real part you calculate first. So 10 divide by 1.44 times 10 to the power of 5. So you get this value. Uh, but I don't prefer to write it this way, but it's okay. You can write it. If you are familiar with this, You can write it this way, or you just write the actual number. The actual number. So 10 divided by 144,000. So you can get uh, it's supposed to be 6.94 times 10 to the power of negative 6, but they take it out. It's okay. You can write it like this. So try to do until you get this format. If not, you can just write it like this. So I prefer you to write it like this. Okay. So once you complete the real part, so you go for the imaginary part. So 6 divided by 1.44 times 10 to the power 5. So you can get 41.6 times 10 to the power of negative 6. Okay, so you can write it as a PU. Okay, so this is one example for you. I already gave. So try it yourself. You try it yourself to understand how the thing works. Okay, refer back. I will normally give you back this lecture video. So try to listen back for you to understand how to do. Okay, this is for you to try at home. Okay, so I'm not going to discuss now. We will be discussing this, but I already gave you the solution. It's okay. I just do some discussion with you. Okay, so it's given a question. Okay, at 8 kilowatt source delivers power to a 72 ohm resistor and 200 kilowatt electrical boiler as shown in figure 1. Okay, so this is the question. So usually the questions will be like this, which is related to real life machines and also power. Okay, power machines. Okay, so here we are using electric boiler. So this is the load, electric boiler. So we can see the source is 8 kilowatt or kilovolt. So the resistor here is 72 ohm, and boiler is 200 kilowatt. Okay, so base values are given. Okay, earlier the question they asked to find base value. Here the base value given, so you need to find the actual value. Okay, then draw the equivalent per unit circuit diagram. So when they ask you to draw the equivalent circuit diagram, so you need to draw the same. Just these values must be replaced with PU values. Okay, so this is the answer. Okay, so here we can see you have a load current. So one current is going here, one more current going here based on Kirchhoff law. Okay, so we can see. Okay, first we calculate for this. So this is E1. So we call it E1. So 8 kilowatt divided by 4 kilowatt. Why 8 kilovolt? Because the source is 8 kilovolt and the base base for the voltage is 4 kilovolt. So you divide, you get 2 pu. So imagine in the exam you get 2 marks. So just by one line. Okay, so you get 2 pu. So calculate for resistance. So resistance is 72 divided by impedance 72 divided by 32. Sorry, you get 2.25 pu. Then the power is given 200 kilowatt, and here the power is supposed to be S. Okay, by times they can use P also if it's not complex power. It's a 500 kilowatt. So 200 divided by 500. So you get 0.4 pu, and I. So I is a bit tricky because you have 2. Okay, first you need to calculate for this. So you are taking directly from here. So voltage division. Sorry, current division. So E1 is 2 pu divided by R is 2.25. uh, okay, or Z. Okay, so you get 0.889 EU. Okay, so you get for this, and then for this part, so you're taking based on power. Okay, so power is 0.4 divided by 2. Okay, you're taking direct because you're calculating the current for this cycle. Okay, power is P equals to VI, the formula. P equals to VI. So you rearrange, you can get this. So you get a 0.4 divided by 2. Uh, so you get a 0.2 PU. Okay, so try to do these two. Okay, so I think we reach end of slide. So try to do these two examples. Okay, one is for this. This is be direct. I already given you the answers. Then you have these questions. For exam, it will be something like this. Okay, something like this, which you will give a real question for you to find the equivalent PU circuit. Okay, so any questions related to this? Is there anything you want to ask? Anything?
No, sir.
If understand, put thumbs up. If not understand, put thumbs down. Okay. Can see some reaction. So at least I feel like I'm not talking alone. Okay. So thank you for your response. Okay. So first class, I'm not taking attendance because some of you still registering. But I just want to encourage. I will give this recording in YouTube as well as in Edpuzzle. So if you cannot attend any class, please do the Edpuzzle. I will check the attendance based on that. So normally for Edpuzzle, I will give 1 week for you to listen. So if let's say you cannot attend any class, I'll just go and refer to the Edpuzzle assignment. I will put the same video there, but there you cannot skip. You need to listen and you need to answer in between questions. So, and I will, whatever chapters, I will make it like 30 minutes or 40 minutes maximum. So that you no need, I won't load you too much with information and you can refer based on parts. So if you only miss one certain part, you just go and listen to that part and earn the attendance. So usually it will be like that, but that is for my part. I'm not sure about Prof. One later how you going to do, but for the first half of the semester, it will be hybrid. Uh, so mostly will be online. Okay, whatever I can explain. So if let's say there's something that I cannot really explain online, it's better for me to explain in the classroom. I will either explain it during tutorial, which we will do face to face, or during the class face to face. Okay, so that's the execution for the first half, my part. So the second half, I will leave to Prof One to be set, so you can negotiate with him. Okay, so I think that's all for today. So thank you so much. So we will meet in the next class. Thank you.